Hi, I'm Isaac from SolarCycle, and this is a latest tour of the SolarCycle off-grid tiny home that's solar powered with battery storage. And it's been a while since the last video, but basically we're finishing up the interior, and I can give you a quick tour of how the solar off-grid system works. Quick view of the status. There's still some bare walls, and with all the insulation and electrical wiring is complete. So once that is completed, basically the last would be installing the shower, bathroom, and kitchen. On the top shelf of the doorway is the Iron Edison battery. That's 24 volts, 180 amp hour capacity. And below that, to the side of the door, is the inverter and charge controller. And right now, you can see battery is almost full, and it is a cloudy day. I think it's basically on this kind of full and just kind of topping off the battery, so it's not going to be allowing a ton of energy in when it's basically a full battery. And you can see it's very overcast, so the sun is a little bit blocked by the clouds, but I'm going to show you in a little bit that there's still quite a bit of wattage that panels can actually output. But in order to do that, I have to put a load on the system. So let me go ahead and turn on the inverter. So right now the inverter is in basically trying to detect a load, and there's a little pulsing sound during this process. But when I actually turn on the circuit breaker, the main panel, and then down here I have my sub panel. And now you can hear the inverter is actually on. Believe it's basically, if it detects 5 watts of draw, the inverter actually turns on. And now, let me turn on the light switch. There's the light. Have a CO carbon monoxide / smoke detector, and so this is the first load that's on, and this is all 120 volt, and I'll turn on some more loads. So there's kitchen light. Turn another load on, and that's the bathroom light. I can even turn on the bathroom fan. I can even plug in this small heater, which draws about 5 amps. So we can go back to the inverter, check out the load, says 4 amps. And now you can actually see more accurately what the panel is actually able to output during this power draw under these basically cloudy conditions. And you can see it says 127 watts. And to the battery itself, the battery is at 26.3 volts. 4.7 amps is going into the battery, which under a cloudy day, you'd think clouds would basically make the solar panels basically inactive, but in truth, there's still, and the maximum that the most I've ever seen on this system is a little bit above 700 watts, so maybe 750 watts. So it's more than 10% power output on a very cloudy day. And let's go look at the panels themselves. So that's with just two SunPower 345 watt each panels. And you can see the wiring goes in through the top and into the side of the tiny home. So I'll just take a step back and just show how small and compact these systems can be. And another cool thing that the setup provides is that basically I have a shipping container next to the tiny home with all the wood, table saw, circular saw, chop saw, all battery powered. Then I could recharge all these woodworking equipment with the battery charger that's inside the shipping container. So I actually have a self-contained wood shop that you can see this is a GFCI extension cord that is running underneath the tiny home. And what I can do is actually plug in this cable and into the tiny home, so that this entire tiny home off-grid solar system can then power the lights and recharge all the batteries that I need for all my equipment. So this is a completely off-grid build at this point, and everything fits in the shipping container just nicely. And we're going to finish all the interior walls this way. And the quality of the equipment has basically, compared to a plug-in, there is basically no difference. It's on par with any wall corded tools that are out there. And it's just simple wood storage. And enough to complete this build fairly soon. And so that's basically all there is to it. It's when it comes down to it, the solar energy that you can produce can power all your needs. Now I have everything basically maximum loaded, so what I would say is you probably, with this size of a system, you probably wouldn't want to run this heater all day long. So I'm going to unplug it. This is just for demonstration purposes. But just to show you that even these high load type of equipments, I wouldn't, you wouldn't want to put a giant electric heater in here. It's a small space, it'll heat up just nicely with it, and it's well insulated enough that you don't need a big heater. But I'm just showing that you can pull 5-10 amps off the system that's sized properly, and it acts just like, basically it's just like a regular wall socket at a normal house, and there's really no, it doesn't feel, other than the size is smaller of the space, the creature comforts are basically the same as in a normal house. Other features built into this tiny home, we have a energy recovery ventilator right up on the, basically close to the top of the tiny home ceiling, that basically exchanges air in this tiny home. And what it does is, as it removes stale air, it brings in fresh air, but they mix. They don't like mix directly, but they mix through a special filter that exchanges heat between the two streams, so that if you have a heater on in the inside, basically the heat will, as it exits, it warms the incoming air. That way you don't have to open a window, let all the heat out, and then have to reheat completely cold air from scratch. And so this system is actually designed for a combination solar with the battery and propane for cooking and heating water. However, you could basically purchase a battery that either is double or triple this size, the capacity, and you'd be able to run even stoves, inductive stoves, and all sorts of other equipment if you need, even oxygen concentrators if there's some health issues, or there are actual incinerator toilets that are electric powered. If this battery capacity was increased double to 3 times, including maybe basically double or triple the number of panels, 4 to 6, maybe even 8 panels, you wouldn't have to have any propane at all. But it just goes to show you how small these systems actually are, and that even on a cloudy day you're still generating electricity, and that these systems are actually practical, pretty straightforward to set up, and not as expensive as you might think, considering this literally, when you start to use these types of equipment, let me just show you really quick here, and using the latest technology, when it comes down to what this really is a floating wall socket. I mean, it's kind of crazy to experience. It's kind of crazy experiencing not being tied to the grid. There's this wall socket floating in space, connected just to a battery and a few solar panels, and you're able to turn on everything you would in your normal house, charge power tools. For example, when I was moving this tiny home, the tires had to be pumped up. I literally just plugged the air compressor into the wall socket and inflated the tires to the correct pressure using the tiny home's own self-generated power. I didn't have to drag an extension cord out, hundreds of feet from whatever, some house. So I don't have to go far to power all my equipment. It's all self-contained. And unless you experience that, it probably doesn't sound very compelling, but I can tell you that just charging your phones, I mean, you hear stories about people turning on their cars just to charge their phones when the grid goes down. And here, I don't need a grid, and I can just charge my phone along with, all sorts of power tools. And there's wall sockets that I purchased that have the USB ports built in, USB Type A. It also has the USB Type C ports as well. So the technology available really makes, combined with LED lighting, so these are actually, they look like incandescent lights, but they're called incandescent LEDs. Let's see if the camera can pick up. So these are actually LED lights, tiny little LEDs that are basically inside of a phosphorus coating, and it's actually pulsing very quickly at a certain frequency to make it look like it's incandescent, but they only draw 7 watts. This is not the final light fixture, by the way. This is just temporary. When all the interior walls are installed, the final light fixture will go on top of that, and it's basically kind of a small chandelier style light fixture. But these lights look incredibly beautiful. They only draw 7 watts, look just like incandescent lights, and so that's not the main power concern. Actually, main power draw concerns are things that actually aren't that high powered, but are on for a long period of time, such as ventilation fans, for example. So like the energy recovery ventilator is designed to be on all the time, even though it's barely 100 watts. You'll want to be concerned that over time, the course of a day, is going to draw most of the power. Things like kitchen lights, bathroom lights aren't on as often, so that's not the biggest power draw. Things like a laptop, for example, if you're on there a long time, over time it will draw your battery quite a bit. But all these things are manageable. So, for example, if you noticed the battery draining, there's a little fuel gauge, and you can also see the voltage on the charge controller, 26.7, and basically it's considered completely drained at like 25.6, I think. So if you see it going lower, you can manage that and say, well, maybe I need to save power, and consider maybe saving energy by shutting down the computer in an emergency. But everything will be charged back up once the sun comes back out. And how often are you at home 100% of the time? So you could be at work, at school. During the day, nobody's probably in the space. So it could be charging while you're out and about for a good majority of the day, storing energy. So at night, it'll be charged, and then you could use the energy when you get home at the end of the day. So the way that the system is used during daily, regular activity of just normal way people behave and act during the day and their lifestyles is very compatible with the way that solar energy is stored and delivered. Now, this design, the way I have it right now with the battery and inverter right here, you can hear the inverter has a little bit of noise. I don't know if it can pick up, but it's got a little bit of a buzzing sound. Now, this is just the first prototype. Now, another version of this design, I would probably find a better way to enclose all of this equipment, which is not difficult. It's just this is a prototype, and for demonstration purposes it's very useful to have everything shown and exposed for people to see. But I could imagine this is a 20-foot trailer, tiny home, so I could imagine a slightly longer, maybe 24-foot tiny home with added room to enclose all this space and not take away from the space of the interior. All of these designs I plan to publish eventually and basically have the plans available online for free so people can use it and learn from it. I hope at some point to also post all of the power data coming out of this system, to post that online as well, so that the monitoring of a typical system, and this is probably the smallest system you'd want, and seeing how it performs for everyone to see and showcase if it's usable and for the way that your lifestyle is, and seeing actual real world use, and then provide a service to do custom designs for people who have their certain ideas of how they want their tiny home built. And all this will be done in 3D CAD, almost like Legos, where you can just like adjust the CAD model. So for example, if you want to adjust walls, if you want to place the bathroom in a different orientation or kitchen, that it can be done in a 3D CAD model rather quickly, rather than trying to go to basically a high-end design firm, or paying lots of money for plans, $300 or more, that you may or may not like in the first place. So you can see your plans up front, not having to pay a lot of money, and then go ahead with the design. And as far as electrical, everything done electrically is balanced so that no one socket will be tripping any circuit breakers. So the way that it is, if you're electrical nut, this might interest you. If not, it might confuse you. But basically, on this side of the wall to the left, I have a branch of the circuit powering all the devices that are going to be on for most of the time, which are the fans, the lights, and refrigeration system is going to be down in this corner. And so things that are going to be on for a good majority of the time, I separate into one circuit. The other circuit are for things that are more high current but less often used. So these basically, this is going to be your typical charge port in the living room, but also if you need to plug in a hairdryer, it's basically a circuit that is not used constantly, so it's available to plug in high current bathroom, like I said, hair dryers or computers, whatever is going to be used separately than basically the regular environmental control system. So it's 15 amps per breaker on each side. If I wanted to go with higher current, what I would need is, and the batteries they have now, they sell are 48 volts, and if I wanted to do more circuits, because each inverter can output 30 amps total, I would, and if I wanted, for example, a 20 amp breaker and two 15 amp breakers, I would have to get a second inverter. And I would most likely, if I'm actually using 20 amps in here, which I'm not right now, But if I were, I would also want to double the capacity of this, at least double the capacity of this battery, in order to provide that an extra 20 amp capacity, 20 amp current to whatever you might want to attach. It could be a washer dryer system, and you would, which is totally doable. All you need to do is double the capacity here of this battery and double the amount of panels on the roof. But it's completely scalable, and it's not as difficult as you might think. The wiring is a little tricky, but once you get a grasp of it, it's very straightforward. Another electrical wiring point of interest: inside the main panel, I do have a ground connected to the trailer itself. And let's see if I can show you what I mean. So right here, for example, are the main tie downs for the trailer to the wall of the tiny home. And inside these tie downs is a giant threaded, like basically half-inch, or it's either 3/4 or half-inch threaded rod coming up, and I'm basically tied a thick ground copper wire, which is this gauge, I believe it's 6 gauge, to that threaded rod with washers and nuts, and it's going behind the wall into the main panel, and basically that's my ground for the entire trailer structure. And so all here's the battery cables that are going back behind the wall, coming out of the wall and into the battery. And and that's basically for safety, trying to ground every piece of metal that I can to the main panel. It's a bond that ensures safety for any shorts or any floating pieces of metal, trying to bond it to the main panel, so that if there is a short somewhere, that the circuit breakers here are tripped immediately. That's pretty much it for this tour. I think the next update would probably be when everything's more polished and finished, which will be very soon, and then this will be finally ready to demonstrate to the public, sell, and provide services for building tiny homes for customers. So that's about it. And if there's any questions or concerns or any comments, feel free to leave them in the comments below. Like, share, and subscribe. And I hope to provide more of these services and demonstrations as time goes on. And it's a great feeling to be completely off-grid, and the entire rest of the build will be using off-grid tools, battery-powered tools, and I'm even using Zipvan and Zipcar to get goods delivered, and also helping hands that are available. And I really appreciate everyone who's helped me so far, and couldn't have done it without those of you who helped me. And I really hope that this design shows and proves that off-grid systems, solar power, battery powered, is completely doable, completely straightforward, completely not as big of a deal as you might think. And let's go, if you are very curious, I can go by the go down to the costs in dollars and cents. What it comes down to is, if you don't have an off-grid system and everything's grid tied in your tiny home, it's a very, very low cost option. We're talking 30-40K at the most material wise, but you probably can get something like that done for 20K. The trailer probably only 5K, 3K materials, and if you all your appliances total, maybe another 5K, and whatever on top of that, whatever custom, if you want fancy things, gets added to that. Off-grid systems, for a system that I have right now, we're looking at least 12K for the entire system, but it doesn't scale. Like double or triple the system isn't exactly double or triple the cost. So double the capacity with a few extra panels, you're looking maybe closer to 18K, 16K, and then with triple the capacity, we're looking more like 20K, 22K. So that gives you an idea of the scale for completely off-grid. We're talking no reliance on any grid power, some sort of RV hookup. You're just dependent on the sun and the battery system. And like I said, even on a cloudy day like today, just to verify, we're still getting close to let's see if I can get this to show up here. We're still getting 184 watts on a cloudy day, and if the system was double or triple the size, you'd be getting closer to 600 watts on a cloudy day. That's pretty incredible. It blew me away. I thought for sure that on a cloudy day this would say 0 when I first started. There was no real good way to predict this other than just trial and error, and it's exceeding my expectations of what is possible with solar power and battery storage. So, and it turned out the only way to find out is to just do it yourself and see how it works. And it could have not worked. It could have been oh, it's cloudy, we have zero watts, no energy. That's not how it turned out. So, you do need high quality components, high quality panels, and make sure you're buying the right equipment. But other than that, it just simply works. Thanks again, and hope to see you soon when everything's finished, everything's painted, and you can finally call this project completed and ready to build a second one and provide services for customers. So thank you very much.